Okay, here we go. Big one. If you're in class and you'd rather do this on paper, I've got these little booklets right here that you can have, and all the stuff is in there. Here's the idea behind this thing, and welcome to Rare Science. We're going to have a couple of weather labs in a row, and my intention is that we get all of the kind of hard ideas out there on these cheat sheets, even if they come at you so fast that it's kind of tough to decipher all at once. You'll do a lab that will have some of these ideas. You come back to the cheat sheets, you use it, and hopefully we kind of come close enough to getting this stuff wrapped up. Okay, so yes, this series of videos, it might be a little intense for a minute, but then as we get into the labs, hopefully we find our stride and we fight through it for a couple days. We'll see how it goes. All right, so I'm going to do the first one right here. I'll break all the other ones into separate videos so that we don't have to watch one like very long video. We'll see how it goes. All right, so good luck to you all. Here we go. Front page, if you have the booklet, storm surge right there. Let's talk about it. And we'll start talking about it by looking at Lake Ontario. Lake Ontario has kind of a long axis here running east-west. It's a little shorter going north-south. What can happen? What does definitely happen is that if you've got strong west winds, in other words, winds that are coming out of this part of Canada and working their way across the lake out of the west towards us, is that those winds can actually hold water up it towards this end of the lake. Now that might feel weird because we're used to water like, water with gravity, it finds its own balance, it finds its own level, right, in a little bottle like this. But take something as long as this lake and put winds at this far side over here and blow them that way. The elevation of the water here can be a little bit higher than it is over here. And it doesn't slosh back because the winds are holding it up. Yes, when the winds change or when the winds calm down or whatever, then it will slosh back, or maybe the winds will push it somewhere else. There's a bit of variability. Sandy Pond right here can be sensitive to that. And I know a lot of us know this area, right? We have a camp right down on the shoreline here. And I've had days where the seawall is all just rocks because the water level's down. And then a west wind is kicked up. This happened like it was, I couldn't get my boat off the seawall because there was no water. Came to school, went back up there the next day, and very strong west winds had blown water back up into our end of the lake, raising it in Sandy Pond by a couple of inches, which was enough. It was just a little boat you could flip over and land in the water. It was enough to make a difference, right? Now, I'm not talking about our record high and record low water years. We're going to deal with that later in the year. I'm just talking scale of like 6 to 8 inches, maybe, if the winds blow it our way, up and down. So small scale, yes, that happens. Larger scale, a little more scary, is the idea of storm surge. What the deal is here is if we have very strong, I want a darker color than that. If we have very strong winds blowing out of blowing from any direction, right? In this case, the lab you're going to look at, the storm of the century in March of '93, there was very strong winds battering this coast of Florida. So storm surge, let's just like try to define it with as simple a words as we can. Is basically when, winds holds water ashore. How about that? Make it bigger. That's it, right? We can keep it that simple. Very strong winds make it so that like as the waves wash up, they're not washing out. In fact, it kind of holds the whole end of, in this case, the Gulf of Mexico up on the shoreline. It's not as intense as what generally happens in the Great Lakes because the Great Lakes are smaller, the storms are less intense. Here, take a much more intense storm in a much larger body of water, and you can get it to happen. So if we looked at this over here as kind of like a side view of the beach, we'll say that dotted line right there represents sea level. And I know it goes up and down with the tides, right? We all know that, but let's say it's average right about there. Some folks have built houses all over the place, far too close to the ocean. And I know it's pretty. I know why it happens. But you built your house very close to the ocean here. So the idea of storm surge would be that if there's a very strong wind coming off the shoreline, it can actually take sea level from being flat and locally make it a little bit more like tilted. And depending on where your house is, that can be bad news for you. And depending on what the subsurface is that you built your house into. That's it, right? We don't need to like hyperanalyze this. That's it. Water holds. Winds hold the water on shore, and if you were in that region, bad news for you, right? Let's bring up another time this happened. You guys were probably so the storm in '93. I was a sophomore in high school. I was in your shoes, right? More relevant, or not relevant, but more like within your date range of when you were alive. If you remember Superstorm Sandy, that like really affected this area right here, which was like a triple whammy, quadruple whammy. A, it was a very strong storm that took a bizarre turn and headed right into this corner right here. B, this corner is shaped just perfectly to funnel the water up in there. So as it was rushing in this way, the shape of the coastline really allowed it to feed in right here. C, it was during a high tide, of course, just bad luck. D, not only was it a high tide, it's what we earth science students should know what a spring tide means. It was during a spring tide, which means the high tide was even higher than normal. So combine all those things with one heck of a storm, and it pushed a lot of water on shore here. Big damage to these small, narrow barrier islands, um, all along the shoreline on both sides. Enough to like shove water right up into Manhattan and down into the subway systems. Big mess. Staten Island over here, huge mess. It was a major, major, major storm, and the storm surge was the big thing. More than the water like landing and flowing downhill towards the ocean was the impact of the storm surge. All right, that is part one. More to come. Keep it up, folks.